I want to talk today about using the nernst equation for some qualitative applications. In particular, I want to look at what happens to the value of the Ecell if we double the concentration of all reactants in a reaction. And the answer really depends on the particular reaction that we're looking at. Let's look at this reaction first, where we react copper plus 2 with solid zinc. Now, we're going to be changing concentrations, so we're going to be looking at this reaction under non-standard conditions. So in order to look at the value of the Ecell, we need to use the nernst equation. So here's the nernst equation, and the really important part of the nernst equation for us is going to be the Q. So let's look at what the Q tells us about this reaction. So Q is going to equal the concentration of zinc plus 2 over the concentration of copper plus 2. Now, if we try to answer the question, what happens if we double the concentration of all reactants in the reaction? The best way to do this is to pick simple numbers and look at the values we get for Q. So first I'm going to start with making all my concentrations 1. If I do that, that gives me 1 to the first power divided by 1 to the first power, which equals 1. Now I'm going to double everything, so I'm going to make all my concentrations 2. That's going to give me 2 to the first power divided by 2 to the first power, which is also equal to 1. So this doesn't change the value of my Q, so there's no change in the value of the Ecell. Let's look at a different reaction. Let's look at the reaction between solid aluminum and zinc plus 2. Notice that for the balanced chemical equation, we need to have 2's for my aluminums and 3 for my zincs. Let's look at the nernst equation again. In particular, let's look at the value of Q. Actually, I mean the expression for Q. The expression for Q is the concentration of aluminum plus 3 squared over the concentration of zinc plus 2 cubed. So again, we're trying to see what happens if we double everything. So let's fill in simple numbers. Again, we'll start with 1. So if we make all of our concentrations 1, what we get is 1 squared over 1 cubed is equal to 1. So no change from what we had when we had the first reaction. The Q is equal to 1. But let's double everything now. So this time, 2 squared over 2 cubed equals 0.5. So Q decreased. That means the log of Q will decrease. But since we're subtracting this, we're subtracting a smaller number. When Q goes down, the Ecell will increase because we're subtracting a smaller number. Let's look at one last reaction. This time we're reacting solid zinc with chromium plus 3. We're going to do the same thing. We're going to look at the value of Q when we double the concentration and see what happens. This time we have zinc plus 2 cubed over chromium plus 3 squared. When everything is equal to 1, our Q is 1. But when everything is equal to 2, our Q is 2. So Q increases, which means the log of Q also increases. This means we're subtracting a larger number. This is going to make the value of the Ecell decrease because we're subtracting a larger number.